Hi everyone, so what I wanted to do is I wanted to spend a little bit of time going over the data from this lab, and seeing as how I'm not here on Friday, kind of just really thought the best way for me to do that was to record this and put this on YouTube. So what you have in front of you is basically my data, um, and I have that into two tables, and so what we can do right quick is I can go through just very briefly how to set up these tables um, so that you can put them into Word correctly. I'm not saying that the formatting here is the best. One thing though that you do need to do is simply highlight the data, and if you hit Control 1 in Excel, that brings up this Format Cells box. And what I like to do a lot of times is put an outer and then an inner border on everything, so that when you copy this table and paste it, it looks something like that. Now maybe you want to change this around and make it look a little bit better. I'm really just doing this to show you how to put the grid lines around it so that it's not a problem at all when it's time for you to insert it into your lab. The next thing that I want to show you is how to do the graphs for this, because I think the graphs are a little bit more tricky. So let's start off with this first activity that y'all did, which was one where you put dialysis tubing into beakers of water. And the beakers of water were essentially all the same. What was different was what was inside the dialysis tubing, which you're seeing in those rows right there. You had different concentrations of sucrose, going from no sucrose at all to 1 molarity, which is very strong. You had different concentrations of that sucrose in the dialysis tubing. And what we noticed is that the percent change, which if you'll notice is always positive for your dialysis tubing, shows how water was absorbed by your dialysis tubing, which makes sense because in the beaker itself was just pure water, and so water had but no option to go into the dialysis tubing, which you could have guessed already because they had told you in the lab to make sure that you leave a little bit of extra space so that you kind of had this idea that your dialysis tubing would swell up. So what I want to be able to do is graph this. I'm going to highlight the data. I'll hit Insert. I'm going to go to Scatter Plot and choose this first option. And so there's that look. Now in the newer versions of Excel, you can choose the different looks of your tables. Some people prefer this, and that's fine. I kind of like this one, but it's either which way you want to do. I probably would suggest that you come down to your data and you format that axis. You format it with a fixed 0. A maximum obviously is 1.0. A fixed unit of 0.2. And let's see what that does. Okay, so basically that works out perfectly. And then the axis title, of course, that would be concentration in molarity. And you could say of sucrose, I guess, add as much as you want to or need to as you believe. Axis title over here would be percent change. The last thing I want you to be able to do, and you can change that title too if you want to, is right click on that data and you hit add trend line. And when you do that, the linear kind of just pops up automatically, and I hit close, and there it is. Theoretically, it's 0, concentration should be 0. The data doesn't point to that, and that's fine. That's just the way my data was when I ran the lab. But that kind of shows you right there the effect, if you will, concentration. So what we would do with this data, if you were to take an extension, would be to say, well, at 2.0 molarity, the bag should increase by this percentage. One question, or one thing that I want to make sure that everyone is addressing in their business, in their lab, is that you want to identify why the dialysis tubing increased, which I think is a lot due to osmosis. And I think you also want to spend a little bit of time talking about the permeability of your dialysis tubing. And it seems like it's pretty obvious that sucrose didn't leave. We have no proof, but it seems like sucrose didn't leave the dialysis tubing. It seems as though sucrose was staying in the dialysis tubing. It was the water that was going in. So probably want to mention that, throw that out there. So that's good for that first graph. We could simply Control C or copy that, come back over to Word and simply paste that, and of course then you would talk about your process data, what you see. So you write down your facts on the process data, whatever that paragraph would entail. The next thing is this other activity, which is part C. And if you do a little bit of research on my website and you see the years prior, it's really these first two columns that was the requirement for the lab. Now I've kind of extended it to see what apples do. And this is the lab data that I've generated, that I have come up with. And so if we again simply just highlight that data, and to create the chart I would go to Insert and Scatter, or the graph better put, and scatter plot that. I like the way that looks, maybe more so here. It's kind of either which way you want to go about doing it. What's really important, and I wish that you could modify it a little bit more, but sadly you can't. If you can see the cursor, you can see that there is an X axis that runs right along the cursor here. And so what we're noticing is we're noticing a point in time where our line crosses that. If you look at the blue line is being, or the blue dots representing a potato, I'm going to highlight those real quick. I'm going to hit Add Trend Line. And I'm going to do the same thing I did as earlier, but this time I want to display the equation. And we'll come back to that in a second. I'll do the same thing for the red series of data. Add a trend line and make it, again, linear and show the equation. So I have two equations, the equation for the red line and the equation for the blue line, respectively. If you think about it, and let's just focus on the blue line real quick and the potato, it seems like every area above the blue line, it looks like the potato was, if you think about it, gaining mass, and everything below it, the potato was losing mass. And so I think that that has something to do with, again, osmosis and the movement of water. And there's something special that must be happening right at this point. And if you read your lab, they kind of, the lab procedure, they kind of make a, they certainly mention this in the lab. I would venture to say that this point has to be a point of isotonicity. It has to be a point at which there's something going on, and maybe since there's no percent change with respect to water, I suspect that means the water is moving in and out at equilibrium. So that's isotonicity. So is a next question to you, the next question I think would be, why is the potato less? And maybe that might be better answered by asking yourself, why is the apple having a higher isotonicity? And maybe thinking about the way that it tastes. Of course, you can modify the chart title, the axes, labels, all that kind of stuff, and that's great, but showed you how to do that already, so I think that's something you already have situated. And that's all you need to do as far as these charts go.